Yeah, so thank you all for having me. So as Jen said, we're just going to talk about accessing and understanding WVU specific patient data and how to use it for research. I know there's some non-WVU folks on here, but there's always potential for anybody that's not within the WVU medical system to sort of partner with a researcher here to be able to do a larger project using WVU data. And if you have resources available at your sites for folks that know how to abstract clinical data from the medical record, but outside of just doing a chart review, the process is going to be very similar for you all. So. Okay. I clicked twice, but I think it only went once. Okay, good. So just about WVU medical system sort of data that we have access to. So the CTSI has something called the Integrated Data Repository. And essentially what that is a real-time copy of WVU Medicine's EPIC Clarity electronic medical record database. So EPIC is the front end user interface that clinicians use to input data, look at patient records, things like that. Every medical system has a back end data schema or a data warehouse that stores all these different data, including data that clinicians wouldn't even see. For example, things like if you had somebody that's an inpatient that are hooked up onto monitors, we're able to get in and even abstract that level of data because those real-time continuous data variables are stored in Clarity, although they're not going to be shown in EPIC. So if there's ever a situation where you really want to look for granular data, such as something like that, like respiratory rates and blood pressures over time during an admission, those are the kinds of level of granularity that we are able to get to because we access the backside of EPIC, which is again the data warehouse. And what we use this for are data request consults for when folks come to us with a data question. We can run feasibility assessments, that does not require an IRB since we are an honest broker for the hospital. So if you have a project in mind and you don't really want to go through the whole IRB process and all those kinds of things because you're not really sure if there's a large enough patient population or if good enough data exists, we can actually run a query for you before you begin any of those things to tell you like, yep, there's plenty of data. We've got plenty of that, cohort of patients, or we can just kind of tell you it's not worth your time. It's not there. So, maybe think of the next question. Custom data set creation. Again, that just goes back to if you have a question and you have a cohort or a list of variables that you want to be pulled into a large data set for analysis, we do lots of those things. We have a COVID-19 database registry with extremely detailed information related to COVID-19. That includes diagnoses, symptoms, treatments, outcomes. And we can also, go back prior to look at comorbidities prior to COVID. We can look at any of, inpatient stays, admissions, really an enormous amount of data that we can get to. We also have, we created the state's COVID-19 registry, which is in a lot of data, but we also tied in all of the viral variant sequences that were done at the state and at WVU on some of those patients that tested positive. So we can actually look at what variant they had along with the full viral genome. And we were able to actually link about 18,000 of those patients in that registry back to WVU Medicine's EMR. So, we have a really large sample size of folks that are interested in COVID. We can look at those COVID positive patients from that database. We can go back in their electronic medical record. Again, look at comorbidities. We can look at recent procedures. We can look at prior treatments before COVID to really look at different things and determine, did any of those previous diagnoses or procedures or anything that's happened in their life have any outcome on how well or how poorly they did when they had COVID. And we can also break it down by variant to look if the variant had any sort of effect on any of those things. The building of that registry sort of led to the National COVID Cohort Collaborative, the N3C. That's an NIH program that the CTSI leads 16 other CTR sites like the CTSI that participates in that initiative. That is available to anybody. You don't have to be WVU to access that database because it's a national database. I can send out more information to Stacy and Jen that could send out to the group if anybody's interested. But essentially all you would have to do to gain access to that database would be for your institution to sign a data use agreement. And then anybody in the institution can get in there and look. There's lots of different, very health specific groups within the N3C. So there's a there's a pediatrics group that's right now there's a project they're looking at BMIs and cholesterol issues and how things have changed since COVID. There is an ECMO. Sorry, it's not an ECMO group. It is a cardiothoracic domain team. There's a cardiology domain team. There's just a rural health domain team. There's lots of different domain teams that's focus on very specific things that have to do with COVID. So that is something that could definitely be of interest to folks in this group. We have expertise in artificial intelligence, machine learning, and we actually just this past Monday released our new HIPAA compliant high performance compute center here at WVU. That is the first time we've ever had something like this. So we can now run extremely large data sets and analytics on those data sets, deep learning, neural networking. We even have the ability to do image processing on a very large scale. So that's really cool. Very excited about that. We also do a lot of image extraction from the medical record for folks that might be looking at specific, I do a lot of neurology ones where we look at the brain. People are interested. They want a cohort of patients who say had glioblastoma and they want to pull the MRIs or the PET scans of all these different patients and maybe do some markups and then run some artificial intelligence or neural networking on those things, on those images to look for, maybe early predictors or something like that. So it's really up to the PI to determine, but we do have those capabilities. So if you're at WVU, if you're requesting a data set, that would go through our iLab system, which probably most of the WV folks on here are familiar with. It's more or less a ticketing system. We ask for your IRB approval, your HIPAA waiver that would be approved by the IRB, and then also your variable list for what you're wanting to look at. We're always more than happy to sit down and sort of discuss your project with you to determine really what variables you're going to need in order for the correct statistical analysis to be done. I've seen that quite a few times in the past where folks collect their own data. I had one where somebody collected data for about 2 years doing chart reviews. And then they said, oh, I'm ready. I've got my data. They go to the statistician and say, here's what I want to do. Turns out they didn't collect the right amount of data or the right variables to do that analysis. So that's very, very important. If you ever are thinking about doing something like that, talk to somebody from my team, one of the data analysts, one of the biostatisticians, because we want to make sure we get the right data for you to answer the question that you're looking at. Again, so what does the data analyst need from the clinician in order to pull these data? We often get requests that say, just an example, I want patients who tested positive for the flu this year with cancer. We don't really know what that means. That could mean very many different things. Do you mean patients that currently have a diagnosis of cancer? Do you mean patients that are in remission from cancer? Do you mean patients that have ever had cancer? Are there specific cancers you want to exclude? Solid tumor cancers, do you want to exclude? Do you want to exclude blood cancers, bone cancers? There's a lot of different things to think about to make sure that you get the right data to answer, your very specific research question. Your time frame of interest, if there's an index event, for example, getting the flu, that's the index event you want to look at. That's the main outcome that you're looking at. And then your other variables are going to be based around that. ICD and CPT codes of interest. That's very important because that is actually how we abstract data. We don't abstract data by words. We abstract data by specific codes. So all the clinicians on the call are very familiar of how different ICD-10 is from ICD-9. I think when the conversion went over, it added like 800,000 additional diagnoses as compared to ICD-9. So it's much more granular and specific. And it works off of parent and sister codes. So you might look at one code, for example, F11, I know it off the top of my head, that's opioid use disorder, substance use disorder, but it encompasses any diagnosis under that. So if you actually open it and you look at the sister codes, there could be things that in there that you don't want. For example, there could be a code that, it was a history of opioid use disorder. However, the patient may not, they may have not used an opiate. They may be, in long-term recovery. So you may not want to include that patient depending on your question. Again, do you want vitals? Do you want medications? What medications? Are there specific dosages? Do you want to know the frequency they were prescribed? Any of those kinds of things. Outcomes. Do you want to look at death? Do you want to look at hospitalizations, readmissions? So all those kinds of things, we want to think about before you submit your data set, before the analyst starts on it. So the more specific that you can be, the better your data set will be, and more than likely, the better your statistical, relevance will be. So this is just sort of a, how do we abstract data? And the reason for this slide, I've presented these kinds of slides before, and we often get the question of why is it taking so long to get my data? Well, the reason being is we've only got so many data analysts and we have a large amount of requests. And what a lot of people don't realize is that we actually have to write SQL or structured query language, which is a type of coding in order to abstract these data from Clarity. And here's an example of what that looks like that every one of our analysts have to write. And this is just, so you can tell this is COVID-19 PCR positives in the past 7 days. Patient MRN, patient ID, they're looking at specimens received, date and time when they're received. And down here, we're looking at lab info. And this is just a piece of probably a 1,000 line code for that data set. So I like to give that as an example to folks as to, why it might take a couple weeks, maybe a month, just depends on the workload, because it is complicated and time consuming. Again, this is very WVU data specific, but it's sort of how we deliver data. And these are just sort of different types of plans that are allowable for us, they're approved for us to put data into. If there were ever a situation where it was, say, a WVU partner and an outside partner that weren't WVU, and there was a data transfer that would have to happen between either one of the parties, we would have to sort of go through our contracting department and legal department to do a data use agreement. And then we would transfer the data appropriately, typically through a secure file transfer protocol method. Although we do have a few cloud methods that are HIPAA approved. So if that ever came up with somebody, outside of WVU, feel free to ask me any more questions or reach out and I can answer any of those things for you and sort of help you through the process. Again, that was just kind of really wanted to keep it high level, just to sort of give folks some things to think about. So does anybody have any questions just based on that or comments?
Hey, Wes, it's Bill.
Hey, Bill.
The machine learning stuff, what kind of examples do we have with that? Is there something we could do that big data, kind of fits in with primary care and a whole practice-based research network that we're reaching out to get bigger data than we can get? So I didn't know.
Sure. Yeah. So in another question I get about the machine learning and the artificial intelligence, and you sort of hit the nail on the head. In order to do anything using those methods, you need lots of data, a lot of data. You cannot use a small amount of data. You can start with a smaller amount of data to come up with a methodology and an algorithm and something that we think is good and accurate. But in order to validate your methodology, you need large data to look at, accuracy and specificity and things like that. So there are, actually lots of different things you could do. I have some papers that I'm happy to send out to like Stacy so she can send out. We did a lot of machine learning modeling on COVID using a lot of different types of COVID related data, hospital related data, and we've published quite a few of those during the COVID period. But happy to send those to sort of, get your brain going a little bit. And, honestly, the sky is sort of the limit. It's a matter of, we can do it with your research question. It's a matter of, do we have enough data? For example, there was one, I will tell you one good example that would be really relevant, although it's not health specific. So Miriam, who is not on the call, Miriam Kudaverity, she really is our AI ML expert here, one of them. She did a project with a pediatrician at the hospital because they were trying to come up with an algorithm, a machine learning algorithm that would help them determine no-shows. And they actually came up with an algorithm that was about 90% accurate. And it turned out that the Department of Pediatrics was losing probably about $2.5 million a year on no-shows. So they actually developed this algorithm. It was about 90% accurate. It's already got I don't think it's a full patent yet, but they were able to, to start the patent process on this. And the hospital is actually implementing this because, with it as accurate as it is, they can actually double book a lot of these different things. And then one of those patients are going to show up. And they used a lot of different information from the medical record to determine this, model and how it would work. Distance, I know distance was one, distance from WVU. I think they used some socioeconomic information, sort of some ages, some information about the parents. And it was really cool. So that was one thing, for these smaller clinics. I don't know if you deal with a ton of no-shows. I'm sure you still do. But, that's something. And like I said, it's not one health disparity specific, but it was, a problem. And they use these data to sort of come up with a solution to solve that problem. So just tons of things. And I saw some chats pop up, and I will get those papers out to Stacy so you guys can read and look at the methodology that was used and things like that.
Yeah, I just always wonder, like, blood pressure, we get readings at every setting. Sometimes you're in pain and it's up because of that, and we ignore it. Sometimes it's been repeated. The ENT office doesn't repeat it. They just have a high blood pressure. We repeat it. We have a normal one. And just if you could tie that bigger data level in on who to really, hey, this is a problem, we got to fix it, where to get the alerts and some of those kinds of things.
No, absolutely. That's exactly the kind of things that we do. We've not done that specifically, but that's a really good example of something we could do, because we could look at, for example, I'm sure you probably have a good handle on patients that come in and, they're sort of, maybe past users or something like that, maybe looking for pain meds. And we could look at those things historically. We could look at the blood pressures, different vital signs that we could look at to sort of determine pain, if it's real, if that's what's causing the blood pressure to go up, if it's something else, maybe even lab results during the stay or something like that would correlate. We don't always know until we get in, so machine learning is a little bit different, but that sounds like it could be something that would be more artificial intelligence, that could sort of bucket out these people and separate them in all these different ways. And the algorithm would just run, maybe that's a neural networking question. Funny thing about neural networking is that we can input, just as an example, we can input 4 or 5 variables into the algorithm. Okay. Once it goes into the computer, if you're running a neural networking sort of model, it's going to give you outputs, and it's going to tell you this is what it found. The interesting thing is that, so putting the variables in, that's point A, right? Getting the information out is point C. We have no clue about point B. We don't know what the model did. We don't know how it came up with what it did. And we don't know why it determined these things are of importance, but it came up with these, and normally they're very accurate. So neural networking is super interesting. I mean, just to kind of blow your mind a little bit, if you're ever interested, go just Google neural networking and things like that. And that'll kind of make you not sleep at night a little bit, because that's the whole Elon Musk saying that artificial intelligence will be the end of the world. I tend to believe it a little bit. We don't want computers to get too smart, but they are already. So.
Well, hopefully Wes didn't scare any additional questions away. We still have another couple minutes for this section if there may be more feedback or comments.
Hey, Wes, I know I had reached out to you earlier about possibility of some machine learning, predictive models based on the work that we're doing surrounding overdose predictive modeling from outside of West Virginia into West Virginia. At that point, and we had done some statistical models, and we were using those right now. And so at that point, I'd given you one county data. We're close to getting it for 11 counties. So at what point in your mind, based on what you looked at, would this be a feasible project for some artificial intelligence to help give us some insight into developing a predictive model based on those methodologies?
So, what we could do is, I would say if you've got 11 counties worth of data, it's still not enough, but we could use that data to begin to create a model, right? We can go ahead and create a model based upon those variables, look at sort of, its accuracy, maybe run it against a couple different things, sort of tweak it a little bit. And then as you get more data, it becomes more accurate. We run it, we add more things into it, we tweak the model, we, switch this variable and that variable and things like that. So with machine learning and artificial intelligence, the more data and the more variables you can get is going to be much better. But I think if you're at 11 now, that might give us a place to start to begin working on some stuff. So if you have that, go ahead and send it over to me, and I will talk with Brad and Miriam, who do all of the AI ML stuff, and sort of get their opinion on it. And I'm not sure, but we may even be able to get some of that similar data from West Virginia, and we may be able to get a lot more of it and start there. I don't know. Just shoot it over to me, and we'll have a chat with them.
Will do. Thank you so much.
Yeah, absolutely.